There's a moment every autumn when something shifts in the American consciousness. The air turns crisp, leaves begin their transformation, and suddenly, every kitchen in the country seems to be searching for the same thing, the perfect apple pie. But here's what most people never consider. While millions of families are debating whether Granny Smith or Honeycrisp makes the superior filling, somewhere in the heartland of America, a facility the size of 3 football fields is producing 15,000 apple pies every single day. This isn't your grandmother's kitchen. This is industrial perfection meeting century-old tradition, where robotic precision dances with recipes that predate the Civil War. Step inside, and you'll discover a world where the scent of cinnamon mingles with the hum of German-engineered machinery, where every pie that emerges from these production lines carries a secret, a manufacturing marvel that transforms 20 tons of fresh apples into America's most beloved dessert before most of us have finished our morning coffee. What you're about to witness isn't just food production. It's the hidden architecture of comfort itself, the invisible system that ensures that when you crave that slice of nostalgia, it's waiting for you, golden crusted and perfect, in the freezer aisle of your local supermarket. The apple pie factory operates on a scale that would astound even the most experienced home baker. Consider this. A single production line uses more butter in 1 hour than the average household consumes in an entire year. The facility processes approximately 40,000 pounds of apples daily during peak season, each fruit individually inspected by both optical sensors and human eyes trained to detect the slightest imperfection. But here's where it gets fascinating. The apples arriving at this factory aren't random. They're cultivated specifically for industrial pie production, grown in orchards where every tree is positioned with GPS precision to ensure consistent sunlight exposure, resulting in fruits with nearly identical sugar content, acidity levels, and cellular structure. These aren't the apples you'd pick at a farmer's market. These are engineered for destiny, bred over decades to withstand the mechanical peeling process, maintain their shape during high-temperature baking, and deliver that perfect balance between tart and sweet that makes your taste buds sing. The temperature inside a modern apple pie factory tells its own story. Different zones maintain wildly different climates. The dough preparation area hovers at a cool 58 degrees Fahrenheit to prevent premature gluten development, while the baking tunnels reach temperatures that would make a blacksmith comfortable. This thermal choreography isn't accidental. Food scientists have discovered that pie crust achieves its flakiest texture when the fat particles remain solid until the moment they hit oven heat, creating steam pockets that lift and separate the layers. The factory's climate control system, which cost more than most people's houses, maintains these temperature gradients with pharmaceutical precision. Walk from one end of the facility to the other, and you'll experience a 40-degree temperature swing, each zone optimized for a specific stage of pie creation. Here's something that will change how you think about apple pie forever. The filling you love isn't cooked the way you'd imagine. In your home kitchen, you'd simmer apples with sugar and spices until they reach that perfect consistency. But in a factory producing thousands of pies daily, that approach would be impossibly slow. Instead, engineers have developed a process called flash cooking, where apple slices pass through a pressurized steam chamber for exactly 47 seconds. During this brief window, the fruit's cellular structure breaks down just enough to release pectin, nature's thickening agent, while maintaining the integrity of individual pieces. The temperature during this process reaches 212 degrees Fahrenheit, the exact boiling point of water, creating a controlled environment where science and tradition merge. The result is filling that behaves identically whether it's baked immediately or frozen for 6 months, a consistency that home bakers spend years trying to master. The spice blend used in these pies contains a secret that most consumers never suspect. While the ingredient label lists cinnamon, nutmeg, and natural flavors, what it doesn't reveal is the extraordinary complexity behind that simple description. The cinnamon alone comes from 3 different countries: Ceylon cinnamon from Sri Lanka for its delicate, sweet notes, Indonesian cassia for depth and warmth, and Vietnamese cinnamon for that distinctive spicy kick. These varieties are blended in proportions that food scientists adjusted over 18 months of testing, conducting more than 300 taste panels before settling on the final ratio. The nutmeg is even more particular. It must be ground within 72 hours of use because the essential oils that create its distinctive aroma are remarkably volatile. The factory maintains a dedicated spice room where humidity is controlled to the decimal point, and every batch of seasoning is tested using gas chromatography to ensure chemical consistency. This level of precision means that whether you buy a pie in Maine or California, in January or July, the flavor profile remains absolutely identical. The crust represents perhaps the most impressive engineering challenge in the entire operation. Achieving that perfect balance, flaky enough to shatter at the touch of a fork, yet sturdy enough to contain hot filling without becoming soggy, requires understanding the molecular structure of wheat gluten and fat in ways that would make a chemist proud. The factory uses a proprietary flour blend that includes a small percentage of cake flour, which has lower protein content than all-purpose flour. This reduces gluten formation, creating a more tender crust. But here's the remarkable part. The water used in the dough is chilled to 34 degrees Fahrenheit, just 2 degrees above freezing. At this temperature, fat particles in the butter remain solid during mixing, creating distinct layers rather than incorporating uniformly into the flour. When this laminated dough hits oven heat, those fat layers melt, creating steam that pushes the flour layers apart, resulting in that characteristic flakiness. The mixing time is controlled to the second, exactly 4 minutes and 20 seconds. Go longer, and you develop too much gluten, creating a tough crust. Go shorter, and the ingredients don't integrate properly, leading to a crumbly texture that falls apart. The factory's quality control measures border on obsessive. Every hour, a pie is pulled from the production line and subjected to what employees call the destruction test. A technician uses a penetrometer, a device that measures the force required to pierce the crust to ensure consistency. The target is between 800 and 1,000 grams of force. Too low, and the crust is undercooked. Too high, and it's overdone. The filling temperature is checked with infrared thermometers, the color is analyzed using spectrophotometry, and the weight is verified to ensure each pie contains exactly the advertised amount of filling. But perhaps most surprisingly, there's a human element that technology can't replace. Master bakers, individuals with decades of experience, randomly inspect pies throughout each shift, cutting them open and evaluating them based on criteria that no machine can measure. The way the filling clings to the crust, the aroma that escapes when the pie is first cut, the visual appeal of the apple pieces suspended in that glossy, cinnamon-scented gel. Now, let's talk about something truly mind-bending: the apple-to-pie transformation timeline. From the moment fresh apples roll off delivery trucks to the instant finished pies enter the blast freezer, exactly 3 hours and 42 minutes elapse. In that narrow window, fruit becomes dessert through a carefully orchestrated sequence that involves 23 distinct steps and crosses the hands, or senses, of both humans and machines more than 40 times. The speed is necessary because apples, once peeled, begin oxidizing immediately. Even with ascorbic acid treatment to prevent browning, there's a ticking clock on freshness. The factory's entire layout is designed around this temporal constraint, with each station positioned to minimize transport time. Conveyor systems move at precisely calculated speeds. Too fast, and delicate components get damaged. Too slow, and production targets aren't met. The choreography is so precise that if you were to stand in one spot and watch, you'd see a continuous stream of pies in various stages of completion flowing past like a river of American tradition. The raw materials arrive at this facility with a precision that rivals a Swiss watch. Apples come from contracted orchards across 7 states, each region selected for specific characteristics. Washington State provides apples with high firmness ratings that hold their shape during processing. Michigan contributes varieties with elevated acidity that balances the sweetness of the filling. New York orchards supply apples with complex flavor profiles that add depth. These fruits don't arrive randomly. They're scheduled based on ripeness windows measured in days, sometimes hours. The factory's procurement system uses satellite imagery and weather data to predict harvest times months in advance, ensuring a continuous supply of fruit at peak condition. When trucks arrive at the receiving dock, samples from each load undergo immediate testing. Sugar content is measured using refractometers, firmness is assessed with pressure testers, and acidity is determined through titration. Only apples that meet every specification proceed to the production floor. Those that fall short are diverted to other uses: juice production, animal feed, or composting. Nothing is wasted, but nothing substandard makes it into America's pie. The butter used in these crusts deserves its own documentary. The factory contracts with dairy producers who maintain herds of cows fed specific diets designed to produce milk with optimal fat composition for pastry production. The butter arrives in 50-pound blocks, each stamped with production data that traces it back to the exact day it was churned and the specific creamery that produced it. Before use, this butter is tempered, brought to a precise temperature that makes it pliable enough to work with but cold enough to maintain its structure. The tempering room operates at 42 degrees Fahrenheit, and workers wear insulated clothing as they prepare the day's supply. This attention to butter temperature isn't mere perfectionism. It's the difference between a crust that melts in your mouth and one that tastes like cardboard. The molecular structure of milk fat changes dramatically based on temperature, and the factory has identified the exact thermal sweet spot where it performs optimally in laminated dough. Here's something that would surprise most consumers. The factory operates 24 hours a day during peak season, which runs from September through December. Night shift workers produce the same quality pies as day shift, thanks to standardized procedures that eliminate human variability. But there's a fascinating rhythm to the operation. During daylight hours, the factory focuses on pies destined for immediate distribution, those that will reach store shelves within 72 hours. Night shifts produce pies intended for long-term frozen storage, allowing slightly different protocols that optimize for freezer life rather than immediate consumption. The difference is subtle: a slightly lower moisture content in the crust, a marginally firmer filling, but it demonstrates the sophisticated understanding these manufacturers have of their product's entire life cycle, from oven to consumer's table, whether that journey takes 3 days or 3 months. The packaging process reveals yet another layer of complexity. Each pie must be cooled to exactly 38 degrees Fahrenheit before packaging, warm enough that condensation doesn't form inside the wrapper, cool enough that the filling has set properly. The cooling tunnel uses forced air circulation at calculated velocities, creating a wind chill effect that accelerates heat transfer without drying out the crust. Once cooled, pies move through a metal detector. Yes, a metal detector that can identify fragments as small as 2 millimeters, ensuring no machinery particles have contaminated the product. Then comes the wrapper application, a ballet of mechanical arms that fold, seal, and label each pie in 1.3 seconds. The packaging material itself is engineered specifically for frozen pies, with multiple layers that prevent freezer burn while allowing the crust to breathe just enough to maintain texture. The science behind this seemingly simple plastic wrapper involved years of polymer research and represents a minor miracle of food packaging technology. The factory's waste management system demonstrates an impressive commitment to sustainability. Apple peels and cores, which constitute roughly 30% of incoming fruit weight, are processed into pectin, which is sold to jam manufacturers. The small percentage of pies that fail quality control are broken down, with filling going to animal feed operations and crust material being composted. Even the cardboard boxes that deliver ingredients are baled and sold to recycling facilities. The facility operates its own water treatment plant, cleaning and recirculating water used in the washing and blanching processes. Heat recovery systems capture thermal energy from ovens and use it to warm other areas of the factory. These aren't just feel-good measures, they're economically driven decisions that reduce operating costs while minimizing environmental impact. In an industry where profit margins can be razor-thin, efficiency isn't optional, it's survival. The human element in this highly automated facility remains crucial. While robots handle repetitive tasks, skilled workers oversee quality, adjust processes based on subtle variations in ingredients, and make judgment calls that no algorithm can replicate. The master baker who supervises each shift has typically spent 15 to 20 years in the industry, developing an intuitive understanding of how dough should feel, how filling should flow, how a properly baked pie should sound when tapped. These individuals earn salaries that reflect their expertise, and the factory invests heavily in their ongoing training, sending them to culinary conferences and workshops where the latest food science research is presented. This blend of human expertise and mechanical precision creates a production environment that honors tradition while embracing innovation. Every apple pie that leaves this factory carries with it a story of American agricultural excellence, food science innovation, and manufacturing precision. It represents the culmination of centuries of recipe development, decades of engineering advancement, and countless hours of human craftsmanship. When you slide that frozen pie into your oven and your kitchen fills with the aroma of baking apples and cinnamon, you're experiencing the final chapter of an extraordinary journey, one that began in carefully managed orchards, passed through facilities where science and tradition dance together, and ends at your table, connecting you to a dessert tradition that's as American as, well, apple pie. But the story of industrial food production doesn't end with pie. Have you ever wondered how factories transform simple tree sap into the golden liquid that defines breakfast across North America? The process of creating maple syrup at industrial scale involves evaporation systems that process thousands of gallons per hour, vacuum technology that defies traditional cooking methods, and quality control measures that can detect flavor variations invisible to the human palate. The journey from frozen forests to your pancake stack involves thermal engineering that would impress NASA scientists, filtration systems borrowed from pharmaceutical manufacturing, and bottling precision that ensures every container holds exactly the same amber perfection. Modern maple syrup facilities operate with a technological sophistication that transforms one of nature's oldest sweeteners into a product of remarkable consistency. That story is waiting for you in the next video that just appeared on your screen. If you've enjoyed this behind-the-scenes look at how one of America's favorite desserts is made at industrial scale, subscribe to the channel for more fascinating explorations of the manufacturing processes that create everyday products. And here's a question for you. After learning about the precision and science involved in factory-made apple pies, do you think they're superior to homemade versions, or does the human touch in a home kitchen create something that machines can never replicate? Share your thoughts in the comments below. I read every single one, and your perspectives always add depth to these conversations. Until next time, keep questioning the world around you, because the most ordinary objects often hide the most extraordinary stories.